Now that we have a good understanding of the basic TypeScript features and what TypeScript adds, and we also understand how the TypeScript compiler works, let's have a look at what else TypeScript has to offer, specifically when it comes to modern JavaScript syntax. Now, this is a difficult, a pretty vague term, but in the end, what I mean by that are JavaScript features which have been around for a few years by now and which are well supported in modern browsers, but which don't necessarily run in all, especially in older browsers, and there especially in Internet Explorer. I'm talking about things like let, const, arrow functions, destructuring syntax, spread operator, and so on. So if that is something you absolutely know, you can skip this module because I will also refresh the knowledge on these topics, but I'll also explain what TypeScript does with these things, with this syntax, though the short story is TypeScript compiles it such that it works. Nonetheless, we'll take a look at that, but you can skip this module if that's all stuff you already know. You can just have a look at the curriculum and see if there is any lecture in this module which might still be interesting to you. Otherwise, I'll see you after this module. If you're not sure about these features, if you know JavaScript regarding var and so on, but you don't know what the let or const keyword really means, then you should stick with me and dive into this module. For that, I got a brand new project setup. You find it attached. And you always need to run npm install first in these projects. Don't forget this to install all dependencies, and thereafter always npm start to start up that development server. Now, this is a project basically as we had it before at the end of last module. tsconfig file with a pretty strict configuration, an app.ts file here, and a dist folder will be generated automatically. By the way, keep this development server running, of course, as you did before. And now we can always compile our code with the tsc command here, or, and that's what I'll do here, tsc-w to enter watch mode and make sure we recompile whenever we change something. So now that's our project setup, and now we'll dive into some next-gen JavaScript features which TypeScript supports and which you should be aware of. Now, before we dive into any features though, attached to this lecture, you find a link to this page. This page basically lists all more or less modern JavaScript features, which browsers support these features, and also which compilers support these features. And there you also find TypeScript. TypeScript combined with Core.js, which is a polyfill provider. But generally, this describes what TypeScript is able to compile. Now, you can always use this resource if you're looking for a specific feature, like let's say the const keyword, where you want to know if TypeScript works with that or not. Then you can see how it works with that and what the restrictions are, which browsers support this. This also, by the way, gives you a hint regarding which browsers you might want to target, regarding the TypeScript target, and so on. So this is a great resource which allows you to switch between different iterations of JavaScript and the features each iteration introduced and how these features are supported. So definitely use this as a resource to find out what you can use, what you can compile, and which target you might need to set. And with that, let's start with one of the most important and obvious and often used introductions, next-gen JavaScript added. By the way, with next-gen JavaScript, I mean ES6 or more recent. And that's let or const what I'm talking about. It allows you to define constants or variables. The difference is that constants, so variables defined with the const keyword, cannot be changed. If you would try to assign a new value here, even if it has the correct type, you'll get an error because it's a constant. Now, this is, by the way, an error that is thrown by TypeScript. In vanilla JavaScript, you would get an error by the browser when you run your code. Here, and that's the idea behind TypeScript, as you learned, we get an error already whilst we're writing the code, because that, of course, is better for us as a developer. It allows us to fix this code earlier before testing it in the console. So, therefore here, if we remove that or comment out this line, now it recompiles and therefore we get no error in the browser as well. So that's const. Let is a variable which can be changed, and therefore, of course, it's similar to var. Var also still exists because JavaScript works such that features aren't suddenly taken away, because then older browsers and their scripts might break. But you shouldn't use var anymore. And why should you not use var anymore? I mean, it makes sense that we have const because that really adds a new feature, constants. But why let? Why did they introduce a new keyword here? Why didn't they stick to var? Let and const have one important difference to var. Well, the obvious difference for const is that the value can't be changed, but for let we also get a difference, and that's the scope in which this variable is available. Now, you should know this concept of scopes in JavaScript, and with var you have a global and a function scope. That means that variables that you define outside of functions are available everywhere in your scripts. Variables defined inside functions are only available in that function. For example, here, if I had a function add, and there I might get two numbers, a and b, then we can add a variable in there with var, result, let's say, and we set result equal to a plus b then, and then we return result. And of course, we could have written this in a shorter way, but I want to show what var does. And this would be fine, and the result would only be available inside of this function. So if I try to console log result here, that would fail because it's only available in the scope of this function. If I define it outside of there, however, everything works because now it's available globally. Therefore, here I can access it. And also the way JavaScript works, you can access variables on a higher level. So inside of a function, you can work with variables scoped to this function, but also variables having a higher scope, like the global scope here. So that's var. Now, for let, the behavior is generally the same. This works, and this works. So it's generally the same for let, but an important difference is that for var, you really only have global and function scope. What about if statements? If we check age greater 20 here, and then in there we create a variable is old and set this to true, then if I console log is old here, we get an error in TypeScript, but actually we would not get one in JavaScript. This code here, if we grab it just to see that it works and move to the JavaScript developer tools and there in the console and we paste it in there and hit enter, you see true is getting printed here. And indeed, if you try to access is old, you get true. So this is old variable is registered globally and not just inside of the if statement. Because with var, JavaScript doesn't know any other scopes than functions and global. And that changes with let. Now, as I said, TypeScript complains nonetheless because this is not good code to write, but technically it would work. With let, that changes. Now with let, this really is only available inside of these curly braces, because let and const introduce a new concept called block scope, which means a variable or constant is always available in the block in which you define it or in any lower blocks. And a block is basically always a snippet surrounded with curly braces, as you have it for an if statement, in a for loop, in a function, or even that's possible if you just add curly braces like this. Any variable defined in here would only be available in that block. And that's a good thing because it forces you to write cleaner code and avoid situations like this. So just to also prove that there is a difference in the browser, if I copy this code using let and I reload my page here and now enter this here, you see I get an error that is old is not defined. We didn't get an error before. Indeed, if I try to output is old, I get that error again. So that's the difference, and therefore let and const is better, not just because we get this constant feature, but also because we are forced to write cleaner code. So let me comment this out to make it work again. Now, besides let and const, another major feature added with next-gen JavaScript, with ES6 specifically, were arrow functions. Now let's rewrite this add function down here, and let's not use the function keyword, but let's instead use this new arrow function syntax. For that, you have to write the function as an expression which you store in a variable. So we could have our add variable, and that can hold a function with the function keyword, as you probably know, but you can now also write a function without the function keyword, with your parameter list, then an arrow, which you construct by using an equal sign and a greater than sign, and then your function body. And this is a valid function. So here you can now also assign parameters and use them and, for example, return it like this. And then if we console log add 2 and 5 here like that, and we save everything, we'll see 7 in the console here. So that is something we can do. That's a new syntax. And one obvious benefit is that it's a bit shorter. We save the function keyword. Another benefit is that it has a couple of nice variations, which make it even more useful. For example, besides this already very short syntax here, you could also, if you just have one expression, omit the curly braces, like this, and then also remove the return statement, and just write this function like that. If you only have one expression, you can omit the curly braces, and the result of that one expression is then automatically returned. So there always is an implicit return statement in front of this. So now this is way shorter than the function alternative, as you can tell. Now again, this only is available though if you have one expression. If you had two expressions or more in the body of that function, you could not use this shorter syntax. You would need a normal function body surrounded with curly braces. Another nice variation is that if you have a function that only takes one parameter, let's say we have our print output function, and that takes output, which is a string or a number, let's say, using a little union type here. And then we console log output here. Then we can, of course, use that to call print output here and add 5 and 2. But now, of course, for one, we can shorten this by removing the curly braces. I'm not really interested in the returned value of console log, but it's also not a problem if we do return it, because as you learned, there is an implicit return statement. But now, since we only have one argument, we can even omit the parentheses around that argument. However, with a type assignment, it will then not work. It would work like that, which works in vanilla JavaScript, but which is not supported in TypeScript because we omit the type assignment. But if we would have the type assignment in a different place, let's say with the function type assigned to the constant, which also gives TypeScript information about what will be stored in a constant, then this would be a syntax we can use. So if we have this setup here, and we give that type information to TypeScript in a different place, then we could use this more concise syntax. Now, arguably, here we don't save a lot because now we had to add that type assignment on our own. But a case where we would save a lot is, for example, if you reach out to a button, which we find in the DOM maybe. And please note here, I have no button in the DOM, but we can try to find one nonetheless. And we then add an event listener. And now, to make sure that TypeScript does not complain because button could be null, as it actually is here, we can wrap this code into an if check, as you learned. And now add an event listener to a click. And now here, we want to pass in a function that should be executed. Well, that can be an anonymous function here, just like that. And that shows us how great arrow functions are. That's really not a lot of code. And in here, we get the event object, which we now could console log, like this. Now here we don't need to specify any function type anywhere, because TypeScript knows what add event listener will provide to us, that this will be an event object. So indeed, TypeScript is able to infer this, even the correct event object based on the event we're listening to. And hence here we can then really take advantage of this very short and concise syntax. So these are some of the variations of arrow functions, and of course I already used arrow functions thus far in the course, just wanted to make it really clear again what they are and what we can do with them. Let's stick to functions. Another nice feature which is available in modern JavaScript is that you can assign default arguments to function parameters. Let's say here in our add function, for some reason we want to have a default value for b. So we know we want to be able to add two numbers together, but in case you call this function with only one number, we'll assume a default for the second argument, or for the second parameter. We can do so by adding an equal sign here in the parameter list and then setting our default value, which of course has to match our type. For example, 1 or whatever the default should be. And now this enables us to call this function with only one argument. So I could call it like this, and TypeScript would not complain because it detects that we have a default argument here, which is then taken for b. And therefore here I get an output of 6 because my default b is 1, and I add 5, which makes 6. Now, one important note about default arguments here, they have to be last in the list. If you assign a default argument to A, for example, we'll have an issue. Why? Because default arguments are not skipped when you call a function. So if I call a function here with one argument, then the arguments I'm passing in here are passed to the parameters in the same order. So calling the function with one argument, 5 in this case, passes this one argument to the first argument here in the parameter list. And since the second argument is not provided with a default, it's not optional, and hence we provide no second argument at all. So TypeScript, or JavaScript actually, does not look at your function definition and guess that you probably want to skip the default argument and provide your value to the non-default one. Instead, it simply adheres to the order, and therefore you should set defaults from the right. So make sure that the parameters for which you don't accept default arguments come first before your default parameters. We also got useful features related to arrays and objects and how we can retrieve the data that's stored in arrays and objects. Now, for that, let's add a new array here. Let's say hobbies, and that can be an array of strings, like sports and cooking here. And now, obviously, we can retrieve elements by index here, like this, for example. But you should know these basic JavaScript things. Next-gen JavaScript introduced a nice feature if we want to extract all values of an array. When could you need that? Well, let's say you have the active hobbies, and that's an array where I do have hiking as a hobby, and now I want to add sports and cooking. Now we can add an item to active hobbies by calling push. By the way, in case you're wondering how I can push to a constant, keep in mind that arrays are objects and objects are reference values. When we push, we change the memory, but not the address. If this doesn't tell you anything, check the additional resources I attached to this lecture regarding that topic. So back to this example then. We can push here, but push, if we push in the hobbies, we'll add hobbies as a new array in the array, so as a new nested array, which TypeScript actually detects, and it tells me that if I want to add a string array to an array of strings, that's not okay. So instead, push takes single values. So we could pass hobbies 0. Actually, push even takes an unlimited amount of arguments so that we can push multiple items in order at once, like that. But that's a bit cumbersome, and that's where the spread operator comes in. It looks like this. It's 3 dots, and yes, this looks strange, but this is a valid JavaScript operator supported by TypeScript. And after that, we specify or we point at the array or object, as you will also learn, that we want to spread. So what this does is it tells JavaScript in the end, because that's a vanilla JavaScript operator available in modern JavaScript. So it tells JavaScript to pull out all the elements of that array and basically add them as a list of values, so not as an array, but a list of individual values in the place where you use that operator. So here, for example, as a list of arguments passed to push. Another place where you could use that is directly when you create a new array. There, you can also spread an existing array into that array. So basically, whenever you need a comma-separated list of values, you can use the spread operator with an array to get such a comma-separated list. That's the idea of the spread operator, and therefore it's really useful for pulling out elements of an array. The spread operator also does not just exist on arrays, it also exists on objects. Let's say we have a person which has a name key, max, and an age key, which is 30. And now we want to create a copied person. Now, if we just assign person like this, what we're doing is actually we're copying the pointer at this person object in memory into this copied person constant. And again, check my reference value resources attached if that doesn't tell you much. So we're not really creating a copy of that object. Now, to create a real copy, we can use the spread operator with objects. We create a new object with curly braces, and then we use the spread operator, 3 dots, with our first object which we want to copy. Now what this does is it pulls out all the elements, but of course here the elements are key value pairs, not single values like in an array. Here we got key value pairs. So these key value pairs are pulled out of there and then can be used anywhere where you need key value pairs, which typically is another object you might be adding them to. So therefore, to this otherwise empty object, the key value pairs of person are now added. And since we created a new object here and just added the key value pairs, we got a perfect copy of the original object and not just of the pointer that points to the object in memory. Kind of related to the spread operator are rest parameters. And for that, I'll again tweak my add function. So I'll comment out all that code up here so that nothing breaks and re-add my add function with any syntax you want, with the function keyword as an arrow function, whatever you want. But now I want to have a special function. I don't want to restrict it to 2 values. I want to be able to add as many values as the user passes in, so that we can basically call add like this: 5, 10, 2, 3.7, and so on, with as many values as you want. If you would want to call it with 10 values, that should also be possible. Now, of course, however, right now it's not possible, as you can clearly see. TypeScript is giving me an error, and correctly so, because I'm accepting no arguments here. Now, of course, I could accept 4 arguments here and assign the correct types, but what if I then call it with 5? As I said, I want to be flexible. That's where rest parameters come in. In the place where you expect a list of values, so not where you want to pass it, but where you want to accept it as incoming values, you can also use the 3 dots and then any name of your choice, like numbers. Now, what this will do is it will merge all incoming parameters, or generally the incoming list of values, comma-separated list of values, into an array. So numbers here will be an array, but of course by default a type of any values, so an array full of any values. And that's not what we should do. We should be more explicit, and here we could say it will be a number array, like that. So now we are defining the correct type, and now we can work with that numbers array. Now we can sum that up in a couple of different ways. We can work with a result variable and then a for loop, because numbers is an array. So here we could loop through numbers and add that to the result. Or we use the reduce method, which is available on arrays. Reduce works such that it performs an operation on every element in an array, returns a result, and then adds these results together. For that, you provide a function to reduce and then a starting value, which here is 0. And then this function, which you pass to reduce, itself takes 2 arguments, and that's the current result, you could say, and it's the current value, which we're looking at, which will be each value of the array once. And then here you can return cur result, which for the first run will be that initial value here, plus cur value. And if you do that, reduce overall here will return a number. So here we can overall return the result of numbers reduced, and hence the add variable or constant here will in the end hold a function which takes a couple of numbers, not an array of numbers, but because of the rest parameters, a list of numbers, which is then merged into an array inside of the function, and which returns a number in the end. So therefore now if we save everything, it should all work, and we see the result, the sum of our little addition here. So that's rest parameters, a really useful feature for accepting an unlimited amount of arguments. And a couple of built-in methods like the push method work exactly that way. You see, push here has this strange parameter definition. Well, that's exactly what we just learned. Push here takes a couple of items for this array, which is an array full of strings. It takes a couple of strings. And this does not mean it takes an array of strings, but instead here with the rest parameters, a comma-separated list of strings, which inside of push is then merged into an array and handled internally. That is the rest parameters syntax. You can even combine this with tuples, by the way. If you know you want to support multiple arguments, but you know how many it will be. So if it's not an unlimited list, then you can also use a tuple type there. And for example, say, I do accept my 3 numbers here, and then I have to remove the 4th argument here, of course, when calling the function, because now I'm pretty clear that I want to get 3 arguments which each are numbers. So of course we could have just added 3 standalone parameters here, but this syntax might still be a bit shorter or easier to set up than adding the 3 parameters. It really depends on your application and your requirements. Here I'll move away from that setup and be more generic and accept as many arguments as I get, because for this function I am indeed able to handle an infinite amount of arguments. Let's stick to arrays and objects. Another important nice syntax, which you'll see a lot in modern JavaScript and also TypeScript projects, is array and object destructuring. How does it work? Well, let's start with our array which we got, the hobbies array, which got 2 hobbies. Let's say you want to extract these 2 hobbies and store them in variables or constants. Of course, we can do that with hobby1 equal hobbies for index 0, which is the first element, and the same maybe with hobby2 for hobbies at index 1. This will pull out these 2 elements and store them in constants. It took us 2 lines of code, and the more elements you want to retrieve, the more lines of code it takes us. Array destructuring allows us to shorten that. With array destructuring, which also works with let, by the way, not just with const, you add square brackets on the left side of the equal sign, which is an unusual place. Haven't seen that before. And on the right side, you have the array, which you want to destructure. Now, destructure really means that you pull elements out of the array. And here on the left side, between these square brackets, you store them in constants, or if you use let, in variables. So here we could then have hobby1 and hobby2. And what this syntax does is it goes through the hobbies array, takes the first element and stores it in a constant with this name, takes the second element, stores it in a constant with this name. You can even add rest parameters here and have remaining hobbies here. In case the hobbies array had more elements than just 2, then all the remaining elements which you didn't pull out into hobby1 or hobby2 will be stored in a new array called remaining hobbies. So they will be merged together into a new array. By the way, destructuring does not change the original array. So if we console log hobbies, hobby1 and hobby2 here, you'll see that hobbies is still the old array. It's not empty or anything like that. So the values which we pull out, in quotes, are really just copied into new constants or variables, not really removed from the array. Now that's array destructuring. We got the same for objects. We got our person here. Now let's say we want to store name and age in standalone constants or variables, just as array destructuring. Object destructuring works with both const and let. Here I'll go with const, and now we can use curly braces on the left side of the equal sign, also a new syntax, I guess, and have our object or the variable pointing at the object on the right side. Now, by the way, please note, this is not an object type I'm assigning here. I don't have a colon here. It's really just curly braces like this on the left side without a colon after some constant name. So I'm not assigning the type of the value that could be stored in a constant. I'm really just using a special syntax. Because here we now also can refer to property names we have in an object, for example, name and age, to pull the values for these keys out of person and store them in constants of the same name. Now here I'm getting errors because at the very top I already have an age variable, and name turns out to be a globally available variable, which exists anyways. So there, the workaround would be to really just use a different key name here. First name, for example, and now we can pull out the value by that key here. So this is how object destructuring works. The important thing here is, for array destructuring, elements are pulled out in order, because an array is an ordered list. In objects, the order is not always guaranteed, and therefore we don't pull elements out by position, but by key name. So the values or the names you specify here between the curly braces are not arbitrary. You can't come up with names here. These have to be property names you find in the object so that the values for these keys can be pulled out of that object. And then they're stored in constants or variables of the same name. If you would want to override that name, you could do so with a colon here. Again, it's not a type assignment here, it just sets a new name. So this is all JavaScript syntax, has nothing to do with TypeScript. So here we could store this in a username constant, for example, and therefore thereafter we can console log username and age, but not first name, because I basically overrode first name to be named username in the constant which we create when we pull out values here. Age is not overwritten, so we can use it like that. Again, this is not a type assignment here. This is JavaScript syntax where we alias, rename a property we're pulling out of person. Also, just as before with the array, the person object itself is not changed. We really just copy these values out of the object. And therefore, we get this output here. Now, this is it for this module. Obviously, modern JavaScript has a couple of other neat features as well. For example, I'll cover classes in the class module. And in general, this is no JavaScript course. I don't want to bore you with tons of JavaScript knowledge that doesn't really relate to TypeScript. I wanted to mention these specific features because it's good to know that TypeScript helps us use these features in a way that still runs in older browsers. Because that is something which you must never forget. Your code gets compiled. Currently, I have the target set to ES6, and therefore if we check the dist folder, we see const and so on are all available in the app.js file as well. Object destructuring also is available like this there, because all these features are supported in ES6. If I would set the target to ES5, and I comment out lib now so that the correct libs are imported for the ES5 target, which will happen by default, you will see that the generated code now looks quite different. It's way longer, because now we're using var, and TypeScript had to find workarounds for certain syntaxes that are not supported in ES5 JavaScript. For example, the destructuring syntax was removed. So that's an important thing to always keep in mind. TypeScript compiles your code not just from TypeScript-only features to regular JavaScript, but also from modern JavaScript to old JavaScript, if you tell TypeScript to do so. In this module, let's dive into classes and interfaces. Now, the concept of classes might not totally be new to you. Classes also exist in vanilla JavaScript, in modern vanilla JavaScript at least. But if you haven't really worked with modern JavaScript, then you might not know classes, or if you're relatively new to JavaScript, you might also not know about them yet. So I'll introduce you to classes in this module as well. And entirely new in JavaScript world at least are interfaces. So in this module, we'll explore what these things are and why we use them, and we'll have a detailed look at classes and there also the concept called inheritance, and at interfaces, what they bring to the table, how they're compiled to JavaScript, and why we might use these features. To understand classes, let's understand object-oriented programming. Now, depending on your level of knowledge, and if you worked with modern JavaScript and maybe also some other programming languages, you might be aware of what classes are there for and what OOP, object-oriented programming, is all about. So therefore, you can also skip this lecture to jump right ahead to the parts where we write code. Otherwise, definitely stick with me because it is important to understand this. The idea behind object-oriented programming, and classes will be important for that as you will see, is that you work with real-life entities in your code, you could say. So that you work with things in your code, with objects that resemble real-life objects as far as possible at least, to make it easier for you as a developer to reason about your code. For example, we might be building an online shop and there we might have a product list. We might want to work with a product list object, therefore, which has everything we need to manage a product list. A method to add products, to delete products, the list itself. So, for example, this might be an object that is responsible for rendering a list of products and for managing it, which were fetched from a server, so from a database. So this product holds all the rendering and fetching and management logic. Now, that's a product list. In our program, in the website we're building, we might also need to work with the individual product though. So we might also want an object or multiple objects, one for each product, that is responsible for managing this single product. It might hold and render the details about that product, maybe allow us to add it to a cart, things like that. So when we want to draw a user interface to the screen, and we want to manage that through JavaScript and therefore through TypeScript, then we could implement this with a product list and a product object, which holds the logic for managing the underlying data, but also for rendering the content on the screen. And of course, therefore, these two objects would kind of be related. We might also have a shopping cart object on our screen, which is responsible for rendering and managing the shopping cart. It's of course also connected to the product, and therefore it holds all the logic we need to render our shopping cart, placing orders and communicating with the server, and so on. So that would be one way of how we could think about the application we're building, how we could split it into logical pieces that make sense to us as humans. And in code, in TypeScript, in JavaScript, in most modern programming languages, this is actively supported because we have objects, which are more complex data structures that hold properties and methods. And of course, we do have that in JavaScript as well. But we might also have classes that help us with that. Now, what's the idea behind classes and what are instances? Well, we got these objects, and when following this object-oriented approach, we could consider splitting our app or our application logic into such objects which manage parts of our logic. Now, connected to the idea of using these objects, which of course do exist in JavaScript, we can use objects there, is the idea of having classes. Objects are the concrete things we work with in our code, the data structures we use to store data, to store methods, to execute methods on. Classes are blueprints for objects. Classes allow us to define how objects should look like, which data they should hold, which methods they should have, so that we can easily build objects based on these classes. And we then call this instances of the classes. So an object then is an instance of a class if it's based on such a class, so that we can quickly replicate multiple objects with the same structure, the same methods, based on the same classes. So classes help us define how objects should look like, which properties and methods they have, and so on. So classes exist to speed up the creation of objects, and it's simply an alternative to using the object literal notation you already know. They simply make it easier, classes simply make it easier to create multiple objects which generally have the same structure and the same methods, and which might only differ in the exact data details which are stored in there. Let's say we have multiple persons we want to represent with objects. Well, each person might have a name and an age. The values will differ, the general structure is the same. So that's the theory. Let's see it in practice. For this, I got a little starting project for you. You find it attached. It's the same starting project we used over and over again. You start the development server with npm start, and then I started the TypeScript compilation in watch mode with tsc-w in a separate terminal. So here in my built-in terminal, I got two tabs, one with the development server, which you should keep up and running so that it watches for changes and reloads the page and keeps the server up and running, and another tab where I have that running TypeScript compilation watcher. Now with that, we can work in the app.ts file, which is empty right now, and start writing some code there. And I want to start right away by defining a class which we can use. We do this by using the class keyword, just like that, and then the name of the class. And there, let's say, we're building an app, a web application, a user interface, for some web tool that allows us to manage our different departments we might have in our company. Maybe we're building some kind of company internal tool, whatever it is, and we need to have multiple departments there. Now we could use objects to manage the data for the different departments, And we might then also add methods there to each object so that we can render that department information onto the screen. And to simplify the creation of these different department objects, which will all look the same, is to create a department class. So we could name this class department. The name is totally up to you. The convention is that it starts with an uppercase character to make it clear that this is a class. Now, if you've been around to JavaScript development for a longer time, you might know the idea of constructor functions, by the way, and classes in the end are syntactic sugar for that, you could say. But we'll see that once we compile our code. So here we have our class department, and now in there, we might have a name property. You can add it just like this, without any let or const in front of it, just like this, directly in the class. And then, of course, you can also assign a type to this. You do that by adding a colon here, and then the type, for example, string. And that's important. This might look like an object, but it isn't an object. In an object, you use key value pairs with a colon to have a key name and then the value for the key. Here, that's not the case. This is a so-called field of a class. You create a class with curly braces as well. But here, this is not a key value pair. This just defines the name of a key you will have in the object, which you will create based on the class. And you define the value type that key will hold in the end. You can also set an initial value here with the equal sign, default, but you don't need to do that. Instead, another thing you commonly have in classes is a special function in there, a so-called method. Functions in objects are simply called methods, which is the constructor method. We can add it like this, and this is a reserved word. Constructor is a reserved keyword understood by TypeScript and by modern JavaScript as well. And this is essentially a function tied to this class and tied to any object you create based on the class, which is executed when the object is being created. So this allows you to basically do some initialization work for the object you're building. Now in there, you could accept an argument. Let's name it n maybe, which could also be of type string. And then you want to store that in your name field here. Well, you can do this by reaching out to name with the this keyword and storing n in it. What this does is it sets the value of the name field, also called property, so of the name property, to the value you're getting on n when a department object is created. Now, how could we create such a department object? Nothing easier than that. Outside of the class, you create it by using the new keyword, which is also built into TypeScript and JavaScript. And then you repeat the name of the class. Then you add parentheses. And this would create a new department object. But the constructor is called at this point of time when you execute this class like this with the new keyword. And the constructor here takes an argument, a string. Now you pass constructor arguments to this department call here, so between these parentheses. So here we could name this accounting, because maybe we're building the accounting department here. Now this will now create a new JavaScript object based on this blueprint. So now we can store this in a constant, for example, and then console log accounting here to see what we get. If we now save that, and we then go back to our page here, and have a look at the development console here in the DevTools, we should see our department object here. It's a regular JavaScript object, just has this department type attached to it, you could say. And in the end, it's an object with one key value pair, where the key is name, because that's what we defined up there. And the value is accounting. And we have this accounting value here because we're passing this as an argument to the constructor. There we are accepting such a string, and we're storing the value in this field. And fields are in the end just translated to properties the object based on the class will have thereafter. So this is how we can create a simple class and what the general idea is. Now let's see what we actually get in JavaScript. With our basic class, if we now go to the dist folder and we inspect the app.js file, we see what is generated in JavaScript. And there you see we have essentially the same code. Two important differences are that the name field, which we have here, does not exist like this here in the class. This would actually be supported in modern JavaScript, but it depends on the version of JavaScript you're building for. So in ES6 alone, it's not supported actually. And of course, what's also missing is the type assignment. We do have our constructor logic though, and indeed, this is how you do add properties to the to-be-created objects in vanilla JavaScript when not using the latest version of JavaScript where this field syntax would also be supported. So this is what I have in JavaScript. Now it gets interesting, however, if we go to the tsconfig.json file and we switch the target from ES5 to ES6 and comment out lib here so that the correct and recommended libraries are added by TypeScript automatically. If you now save this config file and you go back to app.js, you see something totally different. And that's pretty interesting what we see here. What do we have here? Well, what we in the end have here is a so-called constructor function. A constructor function is something which is built into JavaScript, which has basically been there forever, you could say. And this is vanilla, non-modern JavaScript's way of creating object blueprints. It's a function which is called with the help of the new keyword, and then all of a sudden, magically, this function, even though it has no return statement inside of it, does return something, as you see when we call it here. It returns an object, a new object which will have a name property. So this concept is not new. It's not introduced by modern JavaScript or by TypeScript. The idea of having blueprints for objects has been around in JavaScript for a very long time. In the past, however, we had to use constructor functions, and since this could be a bit unintuitive, especially to developers who might have worked with different programming languages, modern JavaScript introduced the idea of classes, of this cleaner syntax, and TypeScript supports this as well. And because of TypeScript's powerful compilation, you can choose whether you want to compile to the older style, which of course works in more browsers, or into this more modern ES6 style, which we saw before, which looks very much like this here. The key takeaway is that we have this feature built into JavaScript and supported by TypeScript that we can define object blueprints. Now, classes and also constructor functions, which have been around for longer, do not just have properties which you can use to define the general structure of the object. You can also add methods. We do have the constructor method there, but that's just a utility function which is called when you do instantiate the class. Remember, in the past, we only had constructor functions. Now we have that syntactic sugar, but we still have the constructor function which we can add to run any initialization code. You might also want to add a couple of functions, or methods as they're then called, which you can call on the created object. For example, a describe method here on our department class. Now a method is added like this. The name of the method, then no colon, no equal sign, instead parentheses, and then curly braces. The parentheses take any arguments you might need. Now let's say here we don't need any. Otherwise you could add parameters just as you do it in a regular function. And what you typically always need though is a function body or a method body between the curly braces. Here you now define the logic of your method. And there we might want to output the name of the department with a little bit of extra information maybe. We can do this of course here with console log, for example, department colon and then maybe name. However, this would not work. This would look for a variable name which has to exist inside of this describe method or outside of the class as a global variable. And as you see, if I choose age, I get an error for name. I don't do this or don't get this because there actually is a global name variable in the browser in the window object. Nonetheless, this would not refer to this name property here, but to some global name variable outside of this class. To refer to a class property or method from inside of the class, we have to use the this keyword as we do it here in the constructor. This then typically refers back to the concrete instance of this class that was created, and there with the dot notation, we can access all the properties and methods of this instance. In this case, this.name. So if I now down there call accounting.describe like this, the this keyword, when this executes, will refer to this concrete accounting object that was built based on this class. So if I now save that and we reload, we should see this output here, which of course has a typo, but generally it works. Let's now fix the typo here. So this is how we can add a method. Now, one important word about the this keyword, as you probably know if you've worked with JavaScript a bit, the this keyword can be tricky. For example, if I would add another object here, accounting copy, and this is an object which just has the describe method, and there I point at accounting.describe, then if I call accounting copy.describe as a method, what do you think will happen? Do you think we get an error? We certainly get no compilation error. That compiles just fine. But at runtime, we see department undefined. And the reason for that is that what I'm doing is I'm adding a describe property to this object, which is created with the object literal, not based on this class, but just as a dummy object, not based on any specific class you defined. And then the value for this describe property is a pointer at the describe method in my accounting object. So I'm pointing at this method here defined for this concrete object. I'm not executing it, so I'm not passing the value of this function execution to describe. I'm really passing the function itself to describe here. So when I then call describe here on the copy, it does indeed execute the method. This all works correctly. The problem just is, when this method executes, this will not refer to this object this method was part of originally, so not to the accounting object. Instead, this, and that's a good rule of thumb you can memorize, typically refers to the thing which is responsible for calling a method. And responsible for calling the describe method here in this case is accounting copy, because we call describe on accounting copy. So this will refer to the thing in front of the dot here, which is accounting copy. That, however, is an object which has no name property. So when I access this.name, I get an error because this does not refer to an object with a name property. So name yields us undefined indeed. And that's why I'm getting this strange output. That's one thing you have to keep in mind, not just in TypeScript, it's a JavaScript thing, and of course, therefore, it can happen to you in TypeScript as well. Now, to work around this problem, you can add a parameter to this describe method, which is called this. That's a special parameter, a special instruction understood by TypeScript. If you add a parameter named this here, it's not really a parameter which is expected. You still can call describe without passing in any value. Instead, this is interpreted by TypeScript to be a hint regarding what this should be referred to. And now it's important to assign a type to this. And the type here, in this case, should be our class type here, so department. What I'm saying with this is, when describe is executed, this inside of describe, so in this case here, should always refer to an instance that's based on the department class. So an object which in the end would be of type department. And therefore now we actually get an error down there. We get an error here because what we got here is that when we call describe here on accounting copy, we're not calling it on an instance of department, so therefore this will be violated. This, in this case, will not refer to an object of type department. So here we add some extra type safety by adding this dummy parameter, because now if I try to save this, I do get an error related to this line here, because now indeed we would execute some code that would not work as expected. So we have to fix this, for example, by adding a name property here, for that to work, because now TypeScript sees, okay, the object on which you're calling describe now has a name property, just like this expects it to have, because this is based on a department object which also has a name property. So now here, TypeScript would be happy because we added name. If I remove it, we get the error back. With name, however, this works, and we avoid this undefined output from before. So that's important to understand about this, and it's important to be aware of this improvement you could add to your code to make sure that you catch unwanted behaviors like we had down there before. So that was a very basic class. Now, when building classes, they often get more complex than that, and you might want to store more data in there. Let's say a department also should have employees. That could be an array, and initially it might be an empty array. And to also be a bit more precise about what we want to store in there, it could be a string array to keep it relatively simple. Now we could have a method here, add employee. There we want an employee as an argument, which should just be a string in our example. And then we can set this employees push, so push a new employee onto our employees array with this code. Now we could also add another method, print employee information. And there I want to console log this.employees.length. And I also want to console log this.employees itself. Now if we go down here, now we can comment out this code here, which would break again, because we again don't fit the department description with our object down there. And instead here on this accounting department, we can add an employee, let's say Max, and another employee, let's say Manu. And then besides describing it, I also want to get my employee information down there. If we save this, we should get this output, 2 employees, and here is some information. Now that's all nice to have. One problem we have with this class is that we could change employees from outside, not only with add employee, but by directly accessing the employee's property, just as we can do it for the name as well, by the way. So what I mean is we could also go to accounting and then reach out to employees and maybe add another employee at index 2 and there pass in Anna like that. If we do that and we save it, we get 3 employees and we get Anna. Now you might think, well, great, we got another way. Well, when building more complex applications, you typically want to avoid something like this though. You want to make sure that there is one clear path, one way of using your class, and that things like that, alternative ways of using it, are not really supported. Because if you're working in a bigger team, well, then one colleague is going to use this approach for adding an employee, another colleague might use this approach. And you don't want this. You want to have one uniform way of doing this. Also, because maybe in the add employee method, you do more than just add it to the array. Maybe you first of all want to have some validation, etc. in here. So you might have extra code in there, which simply does not execute if you directly assign a new value or add a new value to the array with this line here. So you don't want to permit that employees is accessible like this from outside of the class. And TypeScript has got you covered. You can turn employees here into a private property, a private field, by adding the private keyword in front of it. Now what private means is that employees is now a property which is only accessible from inside the class, so from inside the created object. So any method inside of the department class is able to still work with employees. But you can't access it like this anymore. Here you see I'm now getting an error. If I try to save this, I get a compilation error that the property employees is private and only accessible within the class department. So now we force that when employees should be added to this department, people have to use the add employee method because they get an error if they write code like this. This is a so-called modifier here, the private keyword. And besides private, we also got public, which is the default though. You don't need to add public. So name like this is exactly the same as name with public in front of it. The difference is that public properties are accessible from outside. So for example here, I could also reach out to name and assign a new name here if I wanted to. That is possible. For private properties, this here is not possible. We can only use them from inside. Technically, by the way, JavaScript doesn't know public and private. Only in very modern versions, added recently, such a thing exists. In the past, JavaScript didn't know private or public properties. All properties always were public there. TypeScript introduces this feature, which of course does not work during runtime, however, because JavaScript, until recently, only knew public properties. So this line here throws an error during TypeScript compilation. If we compile it to JavaScript, nonetheless, this code would still execute at runtime without errors, because again, JavaScript on its own, until recently, didn't know this concept, so depending on the version you're compiling for, it still won't know it, and therefore TypeScript only supports this because it checks it during compilation, not at runtime. With it, however, we can avoid code like this and force everyone to write cleaner code. Now that we learned about private and public, I also want to turn name into a private property. And now here we have a little bit of a, not really an issue, but a little bit of an inconvenience. We have that name field here, then we get a value for it here in the constructor, and then we store that value for that field here in the constructor in the field. We can do that, and it's certainly very clear what we're doing here. But in a lot of use cases, you'll have a lot of classes where all the properties you have, all the fields you have, are initialized in the constructor, and therefore often you might find yourself writing a couple of properties, a couple of fields like this at the top, no matter if they're private or public, and then you just repeat all of that down there in the constructor, just to then initialize these values here in the constructor function. You don't have to do that. Instead of doing this double initialization code here, you can get rid of your field definitions up there, and now you see we would get an error, but you can also get rid of this here, and instead now simply add the access modifier in front of the parameter. So if it should be public, add public, let's say for the name, we keep it public now. If it should be private, add private. Here you have to add public because this now is an explicit instruction for TypeScript that tells TypeScript that you want to not just get these arguments here in the constructor, but that you want to create properties for this class with the exact same names. And therefore here we should also rename n to name so that a name property is created on the created class. So this is simply a shortcut for this double initialization code here, where you had to find your fields and then stored the value. Now we're doing it all in one go. We define which arguments the constructor takes, and then for every argument which has such an access modifier in front of it, a property of the same name is created, and the value for the argument is stored in that created property. So now we just have to fix our department creation here and add an ID because I added this new argument. And now what you'll see is that when we call describe down there, and I do actually output the ID there as well, maybe by changing this department to use a string literal here, department this.id, and then here this.name, you will see that this all still works. It compiles without errors here. And here we get the output with our ID and with our name. Because of that little shortcut, we also saved some code for all of that. Kind of related to what you just learned about access modifiers is another modifier, and that's the read-only modifier. Let's say we have certain fields which should not just be private or public, they also shouldn't change after their initialization. For example, the ID should not change thereafter. To make it clear that it shouldn't change, you can add read-only here as well. And you could have added that up here as well. So here you would have also written private read-only. Now the read-only keyword, just like private and public, is introduced by TypeScript. It does not exist in JavaScript. It makes sure that if you try to write to this property thereafter, you fail. So you can only use it once during initialization, but thereafter, let's say for add employee, for whatever reason, I try to change ID to D2, you see we get an error here that I can't assign to ID because it's read-only. So this adds some extra safety to make it really clear that a certain property should only be initialized once and shouldn't change thereafter, a requirement you have quite often for certain properties in your objects. So this can add extra type safety again and make your intentions very clear. Of course, you can always say, well, I'm the one writing the code. I won't do anything I don't want. Well, it's still good to be very clear when you define your code. Because A, you might forget what you wanted to do if you pause working on your code for a couple of weeks or whatever it is. And B, you might be working in a team or sharing your code with other people. And it's generally a good idea to write clear and explicit code that makes your intention very clear. And read-only can help you there because it makes it very clear what your goal is. If we have a look at app.js, as I mentioned, we see neither private nor public nor read-only, because that all only exists in TypeScript, not in JavaScript. We also see something different, which is also interesting. The methods are added to the prototype of our constructor function. Now for this you need to know what prototypes are, and introducing those in this course would be a little bit too much. Attached you find some resources where you can dive into prototypes. It's an important part of JavaScript, especially of JavaScript before we had classes, and it doesn't hurt to understand prototypes if you're a JavaScript developer. Still, here I will not dive deeper into them because it's a pure JavaScript topic, not specific to TypeScript. Indeed, in TypeScript, we typically work less with prototypes because we can do more with classes. And related to that, we got another important class concept, inheritance. So we work with our department quite a bit here, and I created my accounting department. Now, for the application we're building, we might need departments, of course, but we might need more information for the specific types of departments. We might have an IT department, which has an ID, which has a name, which has employees, but which also has administrators, something which only the IT department has, for example. We might have the accounting department, which might also have an ID, a name, and employees, but it might also have, let's say, reports, an array of reports it generated, and so on. So we might have some base properties and also methods, which all departments should have, but then we might have specialized versions of these departments with their own specific properties and methods, which only that department might have. And inheritance can help us implement something like this. So how can we utilize inheritance here? Well, we have our class department. Now let's create these specialized departments. So here we could have a class IT department. And in this class here, I want to utilize the name and the ID and the employees of the general department, but I want to add my own features. Now we can inherit the department class by using the extends keyword here, and then the class we want to inherit. In this case, that's department. Now important, you can only inherit from one class, so you can't inherit from multiple classes if you would need that. So now here I'm inheriting from department, and one consequence is that if I now create an IT department here, I indeed can call it like this with this kind of constructor, even though the IT department class is empty. If we save that, we indeed see it works as before, because when we inherit from another class, the class which inherits automatically gets everything the base class, department in this case, has, including its constructor. So as long as we don't add a dedicated constructor for this inherited class, so for the subclass, the base class's constructor, so this constructor, is automatically used when we instantiate our subclass. So we in the end magically call the base class constructor with the arguments we're passing here. Now we can add our own constructor though by adding constructor here in IT department, and now you see I'm getting errors. For one, we now of course should accept the data we're getting here. Though we could argue the name should not be something we need to pass in here, and it shouldn't also be accounting. But instead here, the name of the department, since it's the IT department class, can always be IT. I still want to accept my ID though, but now I want to essentially forward that, just like the fixed name, IT, to the constructor of department. And for that we have a special keyword we can, and in this case we have to use, and that's super. Whenever you add your own constructor in a class that inherits from another class, you have to add super in the inheriting class, and you have to execute it like a function. Super here calls the constructor of the base class, so department's constructor in this case. And now therefore super takes the arguments of that parent class constructor, the ID and the name. So here I can forward ID, so ID which I'm getting here is just passed to super, and I can hard code a value for the name, like IT. So this will now call the constructor of the base class from inside the subclass. Now important, you have to call super first in your constructor before you do anything with the this keyword. So if you plan on assigning any other special properties here, you have to do that after calling super. And indeed, I want to add my own special properties here. We could add our admins here, let's say as a private, or as a public actually, as a public property, admins. And that should be an array of strings, let's say. Well, then I don't want to forward this to my base class because the department class doesn't want any administrator data. Instead, I want to store this in a property of IT department. So here we can then add admins as a field, which takes a couple of administrators, and store admins in there, or because I'm using public in here, I'm already using that shortcut where a property of the same name will be created and the data we feed into this argument is stored in that automatically created property. Still, to make it clear that super has to be called first, I'll take the longer route, add admins here like that, and then here say this dot admins equals admins. Again, the shortcut would be shorter. I'm doing this here to show and make it really clear that if you are using something that uses the this keyword, you have to do that after calling super. And with that, if we save that, I'm getting an error because I'm not passing in any admins. So let's do that here. Max is the only admin I'm passing in here. Now we can save that and compile that without errors. And now here, indeed, we see our department here. It now has the name IT. And if we console log the entire department, and we maybe also rename this from accounting to IT, and I then console log IT here, of course, renaming that was optional, just makes more sense given that we're building an IT department here. Now that I console log the entire department, we indeed see we got admins, but we also got employees and everything which I set up in my department class here. So that's inheritance in action, a very useful feature, because now, of course, we can also create our accounting department here by extending department, and there we could then add our accounting specific things. So we can still use a constructor here, and now maybe with the shortcut, accept a couple of reports here, which might be a private property. And then we have add report, which takes text, which should be a string. And then we reach out to reports here and push text as an item into the report. And maybe we also have get reports here. And there we just console log this reports, or we name it print reports, therefore makes more sense. And now we would have a very special version of a department with two methods, which the base department doesn't have, and with the extra property, which the base department doesn't have. And still, we get everything from the base department. The name, which I'll set to accounting here, and the ID, which we also forward to the base department constructor. And so with that, down there, if we create our accounting here with new accounting department, we can feed in our ID and then our reports. Let's say that's an empty array initially. Then we can call add report, something went wrong. Never that good, of course, in the accounting, I guess. And then we can also print our reports here like that. And with all of that, it compiles just fine. And we get the reports here, and we see the IT department, for example, wouldn't have any reports. The accounting department does because of inheritance, where we inherit certain features and add our own features. So now that's the basics about inheritance. We can also override methods or properties of our base class. So let's say in the accounting, I want to add my own add employee method. We can do that. We can add our own method here and get the name here, let's say. And now here I want to have a different logic for adding that. Extra if check, where I check if name equals max. Well, then I want to return and not add max as an employee because max is totally unsuited for that. Otherwise, if the name is not max, I want to add the employee. Now, however, we also face another issue. If I try to add this to employees, we see employees is not a known property. The reason for that is that employees is private. And now that's important. Private properties are really only accessible from inside the class in which they're defined, not classes that inherit from that class. So employees is available inside of department, but not in classes based on department. So accounting department doesn't have direct access to the employees property. If we want to grant that access and still make sure that it's not a property that can be changed from outside, we can switch it to protected. Protected is like private, but unlike private, it's now not just available in this class, but also in any class that extends this class. So now we can access employees from inside our accounting department. Here I can now add an employee if it's not max. So therefore now if I go down there and on my accounting, I want to add an employee of the name max, this should not work. If I try to add menu, this should work. So if we now save that and we also output print employee information here and then save that, we should see that indeed we have one employee there, which is menu. Because of my own accounting method logic for add employee, max was not added. So the key takeaway here is that you can override methods of your base class. You can add your own implementation, and then that implementation is used instead of the base class's implementation. And B, you also have to control access to properties with protected. Because if you use private, you're really restricted to this class, whereas protected still makes it inaccessible from outside, but makes it accessible from inside of classes that extend the base class. So that's classes, properties, and inheritance with TypeScript. And as I mentioned, these features also generally are supported in JavaScript, in modern JavaScript, of course, with the exception of type assignments and also with the exception of protected, private, public. These keywords are really only available in TypeScript. Now, it's not all what you can do with classes though. One other neat feature which you also have in vanilla JavaScript and which is also supported in TypeScript are getters and setters. Now let's see that here on the accounting department, for example. Let's say there we have a last report property, which is a private property and it's of type string. So we have that. And then here we initialize this to be our reports property, or this argument we're getting here, there the first value, which of course is basically undefined if we pass in an empty reports array. Now when we add a report, then I want to set this last report equal to text, which is what we add to our reports array. Now last report is private. So we can access it from inside this method, but we won't be able to access it from outside with the dot notation. Now we can add a getter to still make it accessible. A getter is basically a property where you execute a function or a method when you retrieve a value, And that allows you as a developer to add more complex logic. Here, you create a getter by using the get keyword and then any name of your choice, typically closely related to the property you're trying to control the access to. For example, here, we could name it most recent report. Anything like that. Now important, this is defined like a method. So you add parentheses and then curly braces. And now in here, you have to return something. That's important. A getter method has to return something. So here we could return this last report, and then we kind of encapsulate this because this is publicly accessible now. But often you want to have more complex logic here. So here we could check if we have a value here. So if this is truthy, if it's not undefined, then we want to return last report. Otherwise, we might want to return some different logic. For example, let's say otherwise we throw an error message with throw new error, no report found. So now we added more logic, more complex logic to this property, and when we want to retrieve it, we can't directly retrieve this property through the dot notation, but we can use this as a property to in the end run this logic. So how would this work? Well, down there where I create my accounting department, before I add my report, if I try to console log accounting.mostRecentReport, and now important, accounting.mostRecentReport, and now important you access this as a property. So no parentheses here. You don't execute this as a method. You just access it like a normal property. And behind the scenes, this will execute this method up there. So if I try this now, before we added a report, we'll see that this rebuilds without errors, recompiles without errors. But of course here an error is thrown. It's our custom no report found error, because no report was added yet. And since using this as a getter accesses this method here and executes it, if we have no report, we don't make it into this if check or into this if statement, and therefore this line here kicks in. As an alternative, if we would move that down after we added a report, then of course we can save that and we no longer get an error, but instead we output this last report. So that's a getter. And you can also add a setter. A setter is added almost in the same way. You use the set keyword, and then again, any name of your choice, typically a name related to the property which should be set. So here I will reuse most recent report so that we can use this both to read a value and to set a value. And then again, you define this like a method, but now this needs to take an argument, the value which the user would have passed in. And here this should be a string value. And now in here you can run any logic you want to store this. Now here, since we're passing in a value for the most recent report, I in the end want to execute add report. So here a setter could simply be an alternative to the add report method. So in here we can access this add report. This is required since we're inside of the class. We refer to the class and then to this class method here. And now we can just forward value here. Now we could add a more complex logic and also check if value is maybe not defined, if it's falsy, and then just return or throw a new error where we say, please pass in a valid value. That is something we could also do. And now we're using a setter here as well. With that added, we can test it. Down there, I could add most recent report. I could access this on accounting. And just like this, we would read from it, but now by adding an equal sign, we're trying to set a value to that, and that will trigger this setter method. Again, just as before, we don't execute it as a method, but simply access it like a property. Now here, if I pass in an empty string, then we technically do pass in a string, but an empty string will be treated as falsy here, and therefore we should now get an error. So if I save this line of code, if I save the code with this line of code added, we indeed get this error, please pass in a valid value. If I do pass in a valid value though, if I say year-end report here, for example, and I now save this, now you will see this all works and year-end report is part of our reports list. So these are getters and setters, which can be great for encapsulating logic and for adding extra logic that should run when you try to read a property or when you try to set a property. Another nice feature related to properties and methods, which exists also in JavaScript when you're using ES6 or later, but also in TypeScript, are static properties and methods. Static properties and methods allow you to add properties and methods to classes which are not accessed on an instance of the class, so where you don't need to call new class name first, but which you access directly on the class. This is often used for utility functions that you want to group or map to a class logically, or global constants which you also want to store in a class. An example built into JavaScript, which is not defined by TypeScript and not defined by you, but part of JavaScript in the browser, is the math constructor function, or a class if you want to call it like this. That's globally available in JavaScript, where you can access pi as a constant value to give you that pi number, or functions, or methods to be precise, like POW to calculate the power of something. These are methods and properties which you don't access on the instance of math. You don't have to call new math first. Indeed, that won't work. But you access these properties and methods directly on the class itself, so math acts more like a namespace as a grouping mechanism here. And that's a common use case for static methods and properties, and you can add them to your own classes as well. Let's say on department, we want to have the method that helps us create employees. And that is something we might want to be able to access without instantiating department, because we typically instantiate our more specialized versions, IT department and accounting department, and we don't really want to instantiate department just to call a utility method. And therefore we can add a method here, create employee, let's say, where we want to get the name, which is a string, as an argument, and there we want to return something. Now, to make that a static method, which we can access without instantiating this class, we add the static keyword in front of this method. And then in here, we maybe return an object where we have the name property mapped to this name value. Now, of course, that's a very simple method, but you get the idea. Now, to use that, we could go down there where we execute our code. And now let's say we want a new employee 1. Well, then we can just get this with department.create employee and pass in Max, for example. And if I then console log employee 1, we should see an object with a name of Max. So if I save that, indeed here, this is the employee we just created. So this would be a typical example for a static method. We call it directly on the class without the new keyword, and therefore we use the class as a grouping mechanism, you could say. And if you would want to add a static property, you could do that as well. If you had something like the fiscal year here that you currently want to use in your company, you could set this to, let's say, 2020, and then again, to make it available without instantiating this, you could add static in front of this property or in front of that field, and now access that. So now down there, where I console log my created employee, here we can also access department.fiscal year, just like that, without instantiating it. And if we save that, unsurprisingly, we'll see 2020 being logged here. So these are static methods and properties. One important word about them, or one thing you should keep in mind, when you add them on a class, you can't access them from inside your non-static parts. So if you feel like accessing the fiscal year here in the constructor, and you want to console log it here, this, as you can see, will not work. I'm getting an error here that the property fiscal year is a static member. We can't access this here because the constructor and basically anything in there, all the methods as well, which are not marked with static, and you can't mark the constructor as static, by the way, will not be able to access static properties because this does refer to the instance created based on the class. Well, the static property is not available on an instance because the whole idea behind static properties and static methods is that they're detached from instances. So of course you can't access them with the this keyword. If you would want to use the static property or method from inside the class, you would have to use the class name here to access it. This gives you access to static properties and methods also from inside the class. That's one important thing to keep in mind. So with static properties out of the way, let's come back to inheritance and to a concept related to that. Another way of adding methods to classes which you plan to inherit from. Here's our department class, and as you know, we're inheriting from it on the IT department and the accounting department. Now we do have that describe method here in our department class, and therefore we can call this on any instance based on IT department and accounting department because these classes are based on department and they have access to all the properties and methods of that department base class. Now, as you learned, you can override methods. So for example, here in accounting department, we could add our own describe method version where I want to do something different, where I maybe want to say accounting department ID and then access this.id. Now this would not work here because ID is a private property of department, and therefore we need to turn this into a protected one so that it's available in classes based on this class as well. But with that it should work, and if I now call describe on accounting, which we can do of course, let's maybe comment out these two lines and instead call accounting.describe down there, we should see that new output. And indeed we see accounting department ID D2. Now of course we could also override the describe method in the IT department, but sometimes you don't just want to offer the option of overriding a method because that always exists. You instead want to force the developers working with a certain class or extending a certain class to implement a certain method or to override a certain method. When would you do that? Well, whenever you want to ensure that a certain method is available in all classes based on some base class, in this case department, but when you also know at the same time that the exact implementation will depend on the specific version. So when you can't provide a general method, but you want to enforce that this method exists, but the inheriting classes will need to provide their own implementation because you can't provide a default implementation in the base class. So in such a situation, you might want to have an empty method in your base class and now force all classes based on that class to add and override this method. And you can do so by adding the abstract keyword here. If you add abstract here, you see we get an error that this is only available in an abstract class. So if you have one method or more with abstract in front of the method, you have to add abstract here in front of class as well. And now we're good regarding that. But now you see I have an error here. Describe cannot have an implementation because it is marked as abstract. You have to remove the curly braces, add a semicolon, and instead add the return type this should have. In this case, void. So now you're just defining how this method should look like, what its structure is, but you're not saying anything else besides this. Now, however, we get an error in the IT department because it does not implement the inherited abstract member describe, which means we don't offer the describe method here. And we do have to do that because we're based on the department class, which is abstract and which has such an abstract method, which means this method has to be implemented by any class based on this department class. So now here in IT department, we have to add a describe method. And in there, we can now console log IT department and then do whatever we want. This can be the same implementation as we have it in the accounting department, but it can also be a different one. So now with that, we can save this and it recompiles and we get the almost same output as before, but now we have the different implementations of the describe method in our different classes based on department. Abstract can therefore be very useful if you wanna enforce that all classes based on some other class share some common method or property. You can also have abstract properties. But at the same time, you want to make sure that you don't have to provide the concrete value, the concrete implementation in the base class, but instead the inheriting class has to do that. Also important, abstract classes, so classes marked as abstract with this keyword, can't be instantiated themselves. So you can't instantiate department now. It's basically just a class that's there to be inherited from, so that the inheriting classes can be instantiated, and the inheriting classes are forced to provide concrete implementations for, in this case, the describe method following the structure you laid out here. So with the this keyword referring to a department instance or an instance somehow based on department, including inherited classes that might be in between, and that it doesn't return anything. Now there is one last interesting feature which I also want to introduce, and that would be private constructors. Now what's a private constructor and which use does it have? There is a pattern in object-oriented programming which is called the singleton pattern. The singleton pattern is about ensuring that you always only have exactly one instance of a certain class. This can be useful in scenarios where you somehow can't use static methods or properties, or you don't want to, but at the same time you want to make sure that you can't create multiple objects based on a class, but that you always have exactly one object based on a class. Let's say for our accounting department, we want to make sure that we can only create exactly one object based on this class, because we have exactly one accounting department in our entire company. We might have more than one IT department, but we have exactly one accounting department. Now to enforce this and to avoid that we manually call new accounting department multiple times, we can turn the constructor of the accounting department class into a private constructor by adding the private keyword in front of it. Now what this does is it ensures that we can't call new on this. Here you see I'm getting an error because the constructor is private. So it's only accessible from inside the class, which sounds strange because how do we get inside of the class if we can't create objects based on it anymore? The answer is, well, static methods. A static method can be called on the class itself, so you don't have to instantiate it for that. So here we can add a static method, which we could call getInstance. That name is totally up to you though. Now getInstance will check if we already have an instance of this class, and if not, return a new one. For that we can add a new static property instance, a static private property, so you can put private in front of static, called instance, which will be of type accounting department. So in there we'll store an accounting department instance. So that's what I'm saying here. I have a static property which is accessible on the class itself, but only from inside the class, and the value we store in there will be of type accounting department, so of the class itself. Now we can use this instance property here in getInstance and check if this instance is set. Here inside of static, if we use this, it will refer to the class itself, and then we can access all other static properties on that. The alternative to that would be to use the class name. And now if this is set, I want to return this instance, or again, class name.instance, but this inside of a static method works. It gives us access to the class itself then, unlike this in a non-static method, which gives us access to the instance with which we're trying to work, not what we're doing here. If, however, we don't make it in here, then we have no instance yet. Then I set this instance, so this static instance property, equal to new accounting department. We can use that from inside here, because now we're inside of this class method. So here we can access the private constructor and pass in our ID and our reports array, and then return this instance here. So now we're either returning the one instance we might already have, or if we don't have it yet, we create a new one. But this code, the marked code here, can only run once, because once we have an instance, we make it into this if block, and we return the existing instance. So now if we want to work with the accounting department, instead of creating it like this, we would call const accounting department.get instance, and this returns us a new instance of the accounting department. But if I do this again, I will get the same instance, as you will see if I console log accounting and accounting2 here. You will see that the two should be exactly equal. If we save that and reload, you see down there are my two accounting department objects. They have the same ID, the exact same setup. They are the same object, the same instance, because we only have one instance with this singleton pattern, which is created with the help of the private keyword in front of the constructor. Now, this is arguably an approach which you won't use all the time. The singleton pattern can sometimes be useful. You don't need it all the time, but it's definitely worth to know about it because it is something interesting which you can easily implement with TypeScript thanks to private constructors. Now that's it for classes. We learned about classes themselves, we learned about their properties, the access modifiers, private for internal access, protected for internal access also in inheriting classes, and public for access from everywhere. We also learned about methods which we can add, about static methods and properties, about abstract methods and abstract classes, which is important when we talk about another important concept, the inheritance which we can use. Here we're inheriting from department with the extends keyword. This allows us to share functionalities, properties and methods from the department class with this inheriting class and add our own functionalities or override existing functionalities, either because we have to override, as in the case of describe, which is an abstract method, or because we want to override, like in the case of add employee here in the accounting department. That's not an abstract method in the base class, but of course we still can override it if we want to. We also learned about the singleton pattern and private constructors, which can also be useful sometimes. And therefore, overall, you now hopefully have a good idea of classes and what you can do with them in TypeScript. In general, of course, you need to know what classes and objects and also a bit what prototypes are about in vanilla JavaScript, because that's generally not something introduced by TypeScript, but of course something TypeScript is related to because TypeScript builds up on these default JavaScript features and adds its own magic on top of these features. So now that we covered classes, let's have a look at interfaces. For that, I'm going to rename the app.ts file to classes and add a new app.ts file, which thereafter will be compiled to app.js. And in this app.ts file, we'll now dive into interfaces. So what is an interface? Well, in its simplest version, an interface describes the structure of an object. We can use it to describe how an object should look like. Let me show you an example. We created an interface with the interface keyword, which only exists in TypeScript, not in vanilla JavaScript. Now let's name it person maybe. Again, just like on a class, I start with a capital character, not a must do, but a recommendation and a convention. And now in there, we can define how a person object should look like. Now, unlike a class, we'll not use this as a blueprint, however, just as a custom type, we could say. So here, could say a person should have a name, which is of type string, and an age, which is of type number. So as you can see here, I add properties or field definitions where I have the names of the properties and the types of the values which will be stored in there. What we don't have here are the concrete values. So we don't have this, and if we would try to assign a default value here, we would get an error that an interface can't have an initializer. So we can just define the structure, not the concrete values. We can also add a method here, greet for example. Now just as with properties, we don't add the actual method here though, but just the structure, the description so to say, how it should look like. And to define a method which a person object should have, we add the name of the method, then parentheses, and then the return type. For example, void, and in parentheses you could have any arguments you want to have, like a phrase which should be a type. Again, just the name of the argument and then the type, and then the return type of the method. Of course, you don't have to add parameters. So what can we now do with this person interface? What's the idea behind it? Well, we can now use this to type check an object, for example. We could have a variable, user1, and let's say for some reason we don't initialize it immediately. We just want to eventually store an object in there which has this structure. So then we can assign a type to user1, which could be person. We can use our interface as a type. And now when I assign a value to user1, it has to be an object because interfaces are used to define objects. And it has to be an object with a name property, which must hold a string, a age property, which must hold a number, and a greet method, which must take a phrase argument and then also return nothing. So here in this object, we can add a name, Max, for example. Now here we add the concrete value, and it has to be of that type defined up there. Now separated with a comma, and that's a difference from our interface definition. There we separate our keys, our properties and methods with semicolons. But down there, when we create an object, just as in vanilla JavaScript, we use a comma, then a age, and then also, of course, the greet method. Now, the greet method, as you learned, has to be a method which takes one parameter, phrase, which has to be a string, and where I then want to console log phrase plus, let's say, some white space plus this.name. This could be one implementation of the greet method. Now, what's in there doesn't matter. It's just important that we have this one parameter, which is a string, and that we return nothing. And now this would be a valid user1 object because it satisfies this definition of our interface. So therefore, of course, we can now, for example, call greet and say, hi there, I am, and thereafter we should print the name. So if we now save that and let it reload, we see, hi there, I am Max, and that's coming from our greet method. So this is an interface. It allows us to define the structure of an object. We can use it as a type to type check for objects that must have this structure. Now, if we come back to this interface here, the question is, why do we need this? Wouldn't we have the exact same thing if we would add a custom type here? And there, the difference is just that we have to add an equal sign. And then we're saying the person type is an object which looks like this. And indeed, if we save that, it compiles without errors. So we could replace our interface with such a type, and it works as before. So why do we have an interface then? Well, an interface and a custom type are not exactly the same. Whilst often you can use them interchangeably and you can use an interface instead of a custom type or the other way around, there also are some differences. Well, one major difference is that interfaces can only be used to describe the structure of an object. You can use type for that as well, but inside of a custom type, you can also store other things, like union types and so on, what we did earlier in the course. That sounds like type is therefore more flexible, but the other side of the coin is that interface is clearer. When you define something as an interface, it's super clear that you want to define the structure of an object with that. And indeed, when it comes to defining object types, you more often see interfaces out there in the wild than you see custom types. Now, another thing you can do with interfaces, but you would also be able to do with custom types, is you can implement an interface in a class. What do I mean by that? The reason why you often work with interfaces is that an interface can be used as a contract a class can implement and a class then has to adhere to. Now, what do I mean with that? Let's say our interface is not a person interface with a name and an age, but instead we name it greetable. Now, this might look like a strange name, but in the end, this just says any object that should be treated as greetable has to be an object with a name and with a greet method. So now we could say this here, this user1 variable should hold a greetable object. And of course, now we get an error because we have more than just name and greet. But we could use this interface to share it amongst possibly multiple classes we have to ensure that every class that adheres to this interface has to have a name property and has to have a greet method. So here we could now add a person class. The name is available again because I renamed the interface. And now tell TypeScript that this class should basically adhere to this interface. It should implement this interface. It should follow that contract set up by this interface. We do this by adding the implements keyword after the class name and then the name of our interface, greetable. And you can implement more than one interface. That's a difference compared to inheritance. You can inherit only from one class. You can implement multiple interfaces by simply separating them with a comma. So there we could have another interface if we had one. Here I only have one though. And now the implication of this is that we get an error here because our class incorrectly implements the interface. It does not have the name property. It does not have the greet method. So now we have to set this here in our class, maybe also add a constructor where we get a value for the name and then set it up like this, and where we also add our greet method, where we then might have this logic from down there. Now in our class, we can have more than that. We can have more fields, we can have more methods, we can also extend this class, we can work with this class as we always can. But we're forced to implement this method correctly, to have this name property, because we're implementing this interface. And therefore, interfaces are often used to share functionality amongst different classes, not regarding their concrete implementation. You can't have implementation or values inside of interfaces, but regarding the structure, regarding the features a class should have. It's a bit like working with abstract classes, therefore, the difference being that an interface has no implementation details at all, whereas abstract classes can be a mixture of you have to override this parts and I have a concrete implementation parts. That's an important difference between interfaces and abstract classes. Now with that, however, we have our person class here, and now here, user1 can be created by using new person and feeding in the name, for example. And now you see it's okay that we have this age here in user1 because we built user1 based on person. Person implements greetable, and you can add more than greetable once in a class, but you have to satisfy the conditions set up by the interface. And therefore now if we save everything, we have a valid code. And if we log our user1 down there with console log, we see that it is a normal object with an age and a name in this case, but the key takeaway is that it is based on a class which implements the interface. And you can then also use the interface as a type. Of course, we could have set this to type person, but as you see, using type greetable here also works because the person object, which we store in the user1 class in the end, is based on the greetable interface. It implements this. So that's another powerful feature. You can use an interface as a type on some constant or variable, which will then actually store another class of another type, which in turn is based on the interface type because it implements it. So that's interfaces in a nutshell. A lot of powerful features included. So now that we know about these powerful features, an obvious question is, why would we use that? Why is that helpful? Well, it is useful in situations like this, where we know we want to have a certain set of functionalities, let's say a greet method, and we want to ensure that a class has such a greet method and another class has it maybe as well. Well, then we can implement an interface which forces the existence of this method. So then we can easily share functionality amongst classes, and every class has to add its own implementation, the exact code that should execute when the method is called, but we enforce a certain structure with the help of interfaces. And this can be useful if we then have other parts of our code which rely on that structure. Here we set user1 to be of type greetable, and with that we say we don't care what's inside user, but what has to be in there is a greet method, and we know that it has to be in there because whatever we store in user1 has to be greetable. And that allows us to write truly powerful and flexible code, where we don't have to know everything about an object or everything about a class, but we just know whatever I'm getting here in user1 has to have a greet method. We don't care whether person has anything else. Here we're interested in greet, hence we sent this to greetable, and therefore we can't store anything in user1 which would not have a greet method, because greetable forces whatever you base on it to have such a greet method. Now inside of an interface you can also add the read-only modifier. You cannot add public or private or anything like that. This is not possible on an interface, but you can add read-only to make it clear that this property in whatever object you build based on this interface must only be set once and is read-only thereafter, so that it can't be changed after the object has been initialized. This is also something, if we use a type instead, which you can use on a type if you want to though. So again, these two things are very similar here, but it's more common or seen more often that if you really want to work with an object, you use an interface for that. And read-only is just one other thing you can add there as an extra feature you can set up. With read-only added here, by the way, you see I didn't add it here in the class. I didn't add read-only here. And still, if I now go to user1 and I try to set name to something else, I get an error here already because it's read-only, and of course I also get that if I save it and it tries to compile that. So the interface is really having an effect here once we implement it into our class. Even though I didn't add read-only here, the class knows that it implements greetable and it automatically assumes that the property name, which we have here, which we need to have because of the interface, is read-only because that is what we set up inside of the interface. And that's of course pretty convenient as well. You can also implement inheritance in interfaces. Let's say we have another interface named, and this is the interface which actually makes sure that we have a name property. So now here in person, we could implement greetable and named to be forced to have both a greet method and a name. That is something we could do. Or if we know that greetable things, greetable objects always need to have a name, we could make sure that this greetable interface actually extends the named interface so that together they form a new interface which forces every object based on greetable to have a greet method but also to have a name. And to do that, we can add extends here on the interface as well, and we extend named. Now therefore, as I said, this forms a new interface, which is in the end the interface that forces us to have a greet method, but not just that, it also forces us to have everything the named interface defines, in this case a name property. So if I would remove name here, I would already get an error because this class now incorrectly implements the interface greetable, because the property name is missing. So that's also how we can combine interfaces. Why would we split an interface like this? Well, maybe you have an application where on some objects you only want to force them to have a name and not a greet method, whereas on other objects you need both greet and name. With this split, this is possible. Some objects or some classes can just implement named, and others can implement greetable and are forced to have both greet and a name. So extending interfaces is possible. And there you can also extend more than one. So you can merge multiple interfaces into one single interface. We could merge another interface if we had it, simply separated with a comma. Remember that for classes this was not possible. When you use classes and inheritance, you can only inherit from one class. You can't inherit from multiple classes. For interfaces that is different. For interfaces you can indeed inherit from multiple interfaces because in the end they're all just getting merged together, and in this pure TypeScript feature, which is actually not translated to JavaScript as you will see, we can therefore break the rules set up for JavaScript classes and extend multiple interfaces. Now I mentioned that interfaces are used to define the structure of an object. Now interfaces can also be used to define the structure of a function. So basically as a replacement for the function types you already learned about. Just as a quick refresher, we can define the type of a function, for example with a custom type with the type keyword, add fn for add function, which then could hold a function definition like this. It should return a number and it should take 2 arguments where each argument also is of type number. Now we could create a new function, add here, which is of type add fn, and when we don't initialize it but assign our function later, then of course we have to make sure that this function takes 2 arguments which are of type number, and that in there we also return a number. This is something you can do. This is what you already learned. Now you can also use an interface as an alternative to this custom type. Interfaces are there to define the structure of an object, as I taught you, but in the end functions are just objects, and therefore this is a little exception. You can create function types with interfaces. For that you create an interface, name it addFn to still keep that name here, and now in there you define the function by just adding parentheses with your arguments, a number, b number for example, and then a colon, not an arrow, but a colon here with the return type. So in the end, like you would define a method, as we're doing it here with greet, with the exception that we're now not adding a method name. So we have an anonymous function, if you want to call it like this, in the addFn interface. And TypeScript understands this special syntax of this anonymous function in your interface and understands that you want to use this interface as a function type, and this is how your function should look like. So now we can use addFn here, and indeed if I would try to accept a string here, we would get an error because this is not assignable. We need to have a number instead of a string. So it's simply an alternative to this custom type. Of course, here I would argue using the custom type is probably a bit more common. It's also a bit shorter, but it's a nice alternative syntax to be aware of, especially if you encounter this in some project and you're otherwise lost what this means, this strange anonymous method. Well, it's in the end just a custom function type. Let's come back to interfaces for objects. You can also define optional properties in interfaces and also in classes, as I will show you. For that, you add your property name. Let's say output name here. Can be whatever you want, of course, and that should be a string, but I don't want to force every class based on name to have that. It should be optional whether you want to have that or not. You can specify an optional property by adding a question mark after the property name. This tells TypeScript that this property might exist in classes that implement this interface, but it doesn't have to. And therefore we get no error here in person, even though I don't have an output name property, because it is optional. Now of course I can add output name here and initialize this with some value or use it like any other property, but I don't have to. Now on a class you can also have an optional property. Let's say name here should be optional, because maybe we don't get a value here for n. We can add a question mark here as well in our class. We now just also have to make it optional here in named, otherwise we violate against our interface, which forces this to be a string. Now I'm saying this can be optional, so here it's now optional. And here, when I set this equal to n, I only want to do this if n is truthy, if it is set. So only if it's not an empty string, for example. Otherwise, name will not be set, and that is okay, because I turned it to be an optional property, both here in the interface, but also in my class. So now here, when we construct a new object, we could do this without passing in a name. To allow that, we have to go to the constructor and provide a default value here, or also add a question mark here. This is also allowed. You can add optional parameters either by providing a default fallback value or by adding a question mark, in which case the default value will be undefined. And now we can call this constructor without a value because we have that optional parameter, and because we have the optional property, that is okay. We don't need to initialize it. And hence thereafter, if we greet, Well, this name, of course, will yield undefined. So probably we should check here as well if we got a name, and if we do, we console log this, else we console log hi without any reference to the name because we don't have one. If we save that, everything compiles and we see just hi here because I didn't provide a name. So that would be optional properties, both in a class and in an interface, and also in my constructor list here. And now just to make it really clear again, these three things are only loosely related. You can have an optional property in an interface and then implement it as a non-optional property in the class. You then just have to make sure that your logic is such that this is always initialized, otherwise you get an error, as you just saw. Or you have an optional property in an interface and an optional property in your class, then you don't have to assign a value in all cases here. And in addition, and also totally unrelated here, you can have optional parameters in functions and therefore also in methods, including the constructor method. Optional parameters are defined either with the question mark, where the default value, if not set, is therefore undefined, or simply by assigning a default value like this. Then, as you learned, this is also optional, and the default value will be assumed if you don't pass in a more specific value. So this gives you more flexibility in how you structure your classes, and when we talk about interfaces, how you structure your contracts classes might need to adhere to. There was a lot of talking about interfaces and classes now. Now let's look under the hood and see what JavaScript actually produces or offers as an alternative to interface. We learned that for class code, in the end, it depends on the version we're compiling for. If we compile for ES6 here in the tsconfig, then our output would use the class keyword. Since we compile for ES5 here, we instead see this workaround using constructor functions in the end. What, however, happens for interfaces? Well, let's have a look at the app.js file. And there you see nothing. You'll not see any translations for our interfaces. Add fn, named, greetable. You don't find these things anywhere in app.js. You just find our function here, you find our constructor function for the person object, so basically the translation for the person class, and the other code. You find no reference at any interface. And there's a good reason for that. There is no translation for interfaces. JavaScript doesn't know about this feature. It's a pure TypeScript feature, only available during development and compilation. So you can use it to improve your code. No output for that will end up in your JavaScript files though. So therefore, it's a pure development feature helping you to write better code, clearly structured code, following clear rules. At runtime, no trace will be left of these interfaces. You'll not see anything related to the interfaces in your code. Only functions, classes, and all the other code is compiled and output. Interfaces are simply dumped, you could say. They're used during compilation to check your code, and then they're ignored. There is nothing that would be output for them. And that is it for interfaces and classes. In this module, we had a detailed look at classes and what we can do there. Classes in TypeScript in the end just build up on classes for JavaScript, and I already summarized those a little bit earlier in this module. Interfaces are a different thing. They only exist in TypeScript. They're a pure TypeScript feature helping you to write clear, clearly structured, and very explicit code. They can help you to force classes to have certain features, or objects in general to have a certain structure. They can be used as a function type, as you learned. They allow for optional properties and also for optional methods, by the way, if you add a question mark after the method name. So that is something you can use. And as you just saw, when being compiled, after fulfilling their role of allowing TypeScript to check your code, nothing is emitted for these interfaces. The code is simply dumped. Interfaces nonetheless are a powerful feature to force your classes or your objects to have a certain structure and to clearly describe your idea of how an object should look like. Now, as you learned, You mostly can replace them with custom types if you wanted to. You can also implement custom types, but it simply is more common to use an interface for that, to use an interface if you want to describe an object and if you want to implement it. Also for historic reasons, because in the earlier days of TypeScript, custom types couldn't be implemented or used like interfaces. Now there is more flexibility, but it's still recommended to go for interfaces if you work with objects and if you want to describe their structure. We'll also see them throughout this course over and over again.